Okay, we have one previous video for Chapter 9 now. We're in Algebra II 9.1b, Symmetry with the x and y axis, and I have a couple theorems for you. If you become lost or confused during this video, you can go to the description, click on that previous video, and watch it, and come back. So, in the previous video, 9.1a, we learned that 2 points can be symmetric with respect to a vertical or horizontal line when they're the same distance from the line, measured perpendicular to the line. And the line is the axis of symmetry, and these 2 points are reflections. They're mirror images of each other. And there's types of symmetry in which the x-axis or y-axis is a line of symmetry. So this was the drawing from the previous video, and you can see we've got Q sub 1. This is our image. This is our pre-image Q. We got P sub 1. That's our image. It's a reflection of P, our pre-image. And if I folded this paper over, well, they would match perfectly. See that? Because it's a reflection across this line L. Okay? So here's our first theorem. 2 points are symmetric with respect to the x-axis if and only if their y-coordinates are additive inverses and they have the same x-coordinate. So if the y-coordinates are additive inverses, a positive 5, negative 5, and they have the same x, then they're symmetric to x. Okay, so x is going to be the same when it's symmetric to x, okay? And if we take a look at this, we've got 2 for x with a positive 5 and 2 for x with a negative 5. And that 5 and negative 5 are additive inverses. So they're symmetric with respect to x. X is the same number. The y is an additive inverse. So also, 2 points are symmetric with respect to the y-axis if and only if their x-coordinates are additive inverses. So now we've got a 3, negative 3 for x, and the y is the same, a 6 and a 6. So we've got a negative 3 here, we got a positive 3 here. Those are additive inverses, and the y's are both 6. See that? So then we know the 2 points are symmetric with respect to the y-axis. So if they're symmetric with respect to an axis, it's the one that has the same number. See that? Isn't that a cool trick to remember it that way? So 6 is like an image of 6, even though it's the x that has the additive inverse. See how they kind of flipped? All right? So if it's symmetric with the x, then the y is going to be additive inverse. If it's symmetric to the y, the x is going to be additive inverse. They kind of traded places. See that? So the relation defined by y equals x squared contains the points 2, 4, and negative 2, 4. So we've got a 2, 4 here. Here's x is 2, y is 4. See that? And on this side, we've got a negative 2, 4. So we know that if I folded this right here on this y-axis, that it would fold over onto itself. So that would be our line of symmetry. See that? The 2 and negative 2 are additive inverses of each other. So the second coordinates are the same. They're both 4. For every point xy of the relation, there's another point negative xy. So the relation y equals x squared is symmetric with respect to the y-axis. All right? I'll explain that. So we now have a means of testing a relation for symmetry with respect to the x and y axis when the relation is defined by an equation. So here's our other theorem. When a relation is defined by an equation, the first point is its graph is symmetric with respect to the y-axis if and only if replacing x with negative x produces an equivalent equation. All right? So take a look at this. If we replace x with negative x, so we've got y equals x squared plus 2 for symmetry with respect to the axis. We're going to test for the y-axis. So we're going to replace, for the y-axis, we're going to replace the x with a negative x, just like this theorem says. And if we replace x with negative x, we're going to get y equals negative x squared plus 2. And what happens when we square this? Negative x times negative x makes a positive x squared, doesn't it? So yeah, it is equivalent. So the graph is symmetric with respect to the y-axis. See that? Now the second point is, its graph is symmetric with respect to the x-axis if and only if replacing y with negative y produces an equivalent equation. So now let's take that same equation, y equals x squared plus 2, and let's replace the y with a negative y. So we're going to test for the x-axis. We replace that y with the negative y, and we get negative y equals x squared plus 2. We could also say y equals a negative x squared minus 2. That would give us the same thing as this. Now, this is not equivalent to y equals x squared plus 2. If we have y equals x squared plus 2, it's not equivalent to a negative y. See? So it's not symmetric with respect to the x-axis. That graph is not symmetric with respect to the x-axis. Okay? So we had a couple of theorems for you, and you now can see how you can test this for symmetry that's defined by an equation. Okay? So we're going to continue talking about symmetry. We're going to move on to 9.1c, and we're going to talk about symmetry with respect to the origin, 0, 0. I'm going to add this to the Algebra II playlist. We talked about symmetry in 12.4 back last year in Algebra I. If you'd like to watch that video, there'll be a link. We've only got one previous video for this playlist for Chapter 9, and there'll be a link to that too in this description, so you can just click on it. All right? So I hope this was helpful. I hope you're doing okay. Please hit the like button if you are doing okay, and if this video is making any sense to you. And I hope I'll see you in the next video, and we'll talk about symmetry and origin. All right? Have a great day. Bye.